Hey everyone, how's it going? We're just going to share really quickly how to design a bike from BikeCAD. Once again, you're going to be pulling this up in an app, um, the BikeCAD app. I'm using BikeCAD Pro today just because it's going to be quicker. But what I want to do first is I'm going to find my frame design worksheet. So you need to have your frame design worksheet open, right? So we're going to open our frame design worksheet. And the first thing we're going to do is start designing the frame using our dimensions. So we're going to take, for example, our seat tube length and top tube length. So 350 and 520. We're going to use the frame design model right here. And we are going to set our seat tube length for this mountain bike center to top. And that was 350. And we're also going to set our effective top tube length to 520. And that will change the length. We are going to check our worksheet again for bottom bracket drop at 55. Seat tube angle is 74 and head tube angle is 68. So bottom bracket drop, we're going to change to 55. Seat tube angle is at 74 here, and head tube angle we are going to highlight and change to 68. You can also use the toggle switches here. So if I'm at 68, I could change in half degree increments if I needed to. I do want to make sure that my head tube is the appropriate length for where for this particular bike. Since I'm doing a kid's bike, I'm going to do a relatively short head tube. Now, the tricky part is we do need to do this based on front center distance. So we're going to toggle to front center distance, and that's going to give us our head tube length. We're going to change it to 100 millimeters and set our head tube length. Now, as we learned in class, changing our fork is also going to mess this up. So we're going to leave it for now. I'm personally going to set my saddle height at 520 because I know that's going to work to make it look more realistic. Now, you can just kind of mess with your saddle height. And honestly, it should probably be somewhere between, I'd say, 150 and 200 millimeters more than your seat tube length. So, I could leave it at 500, or I thought 520 looked good. This is just kind of pulling numbers out of the air to just make it look like it should. Now, I'm going to close out this portion. One thing I want to do is hide my fenders. So here's my fender or mudguard design. I'm going to hide those. I'm going to switch my brakes from rim brakes, which I'm going to disclude, and then I'm going to include disc brakes just by clicking on disc and hitting include. I'm not going to change any of the parameters here because those are pretty straightforward. I'm also going to hide my cranks and pedals for the time being. So we're just going to hide everything. And there we go. Oops, pedals we need to hide as well. So we pick pedals out here and we can hide them. Okay, so next thing I'm going to do is change my wheel size. And remember that the only three things that matter are bead seat diameter, width, and overall tire. So we're going to be looking at those on our worksheet. So here we have bead seat diameter at 507, width at 58, and overall tire at 623. So I'm just burning through this, but we're going to do 507, 58, ooh, is the width. And when we change our overall tire diameter to 623, that will bring it back into a more reasonable looking size. So this is our tires as standard 24-inch tires. If your spokes all of a sudden are appearing looking like they're sticking out of the wheels, say larger than the wheel size, so say our spokes ended up being like this, you can really set the ERD to the same as the bead seat diameter, and that will just bring your spokes into a more kind of reasonable position here. So that's one thing you can do. You can also use any standard wheel size you like. So for example, this went to a 20-inch mag. This is going to show me a 24 by 40 by 54, which is pretty close to the 24 by 48 wheel size that I was going to use. And if I really wanted to, I could keep all of this information. It wouldn't let me change it though. So I'm going to go back to custom because I'm going to be using a slightly wider tire. So I'm going to be using a 58 millimeter wide tire, which is going to get me to 623 with the bead seat diameter of 507 and not 6,000, 623. And I can change that width to 58 in case I need that for my top view. Okay, so our wheel size has changed, and there we go. I'm going to change my fork now. Going to fork, I'm going to make it a mountain fork to begin with, and then I'm going to change my sizings based on my worksheet. So on my worksheet, I had my size at 45 rake and 450 axle to crown. So I'm going to change to axle to crown and change this to 450 millimeters and change the rake on the bike to 45, not 445, because that's going to make it all sorts of crazy. 45 millimeters in the air rake. So we can leave it there. My suspension is likely going to be more like 80 millimeters of suspension or of travel. That is how far the fork squishes when it goes. And then you're always going to set sag to about 20% of your travel. So 15 millimeters would be the sag on this fork. That actually ends up bringing up the fork a little bit because it's going to be more extended. So if you want to imagine what sag is, when the rider sits on the fork is going to compress a little bit. So if we made our sag 50 millimeters with the rider on the bike, the fork would sit lower than with the sag at about 15, which is our 20%. So 20% of 80 ends up being approximately 15. Kind of just shooting from the hip there, but like say you were doing like a 120 millimeter travel fork, and you wanted to set your sag at a more reasonable size for that. So 120 times 0.2, that's 20% of it. You'd have your sag set for about 24 millimeters. If I'm going to do 80, excuse me, 80 times 0.2 is equal to 16. So I was pretty much spot on with that 15 millimeters of travel. Now the travel is not going to actually change how much the fork squishes in our drawing because our axle to crown is kind of determining that length. So we've got that set. So the main thing, axle to crown and rake. If you want to mess around with your suspension down here, you can. If you want to make it a non-suspended fork, you can also click off the suspension. And those were measurements that we should have already pulled. I'm going to go back in and check my frame. It's still showing my head tube length at 100. My top tube length got a little bit extended when I changed that. So I'm going to change it back to 520. And then sometimes you just have to toggle back and forth between these two until they kind of average out. So I'm going to change that back. We're almost at 520 there. I'm going to change to 520 and then I'm going to check my front center distance. I'm 0.1 millimeters off. I think we can live with that, but if we're really stressed out about it, we can keep toggling back and forth between those two until we're hitting hundreds all the way around. I also failed to change my chainstay length, so I'm going to go back and look at chainstay 425. We are at 405 currently. We're going to change that. That's going to kick that rear wheel back just a little bit. I mentioned this today in class, but this measurement here, or this piece here, isn't lining up perfectly on center with this piece here. So I can use this measurement. Nope, that's not it. I apologize. It's not going to be that measurement. It's going to be a different measurement. It's going to be up here. So we're not going to use that measurement. We should be all set to go here. We should be in like the 10 range here. If you wanted to add a little bit more stack onto the top of your head tube, you could change that. But that's going to be possibly driven. That's going to move your tube down. I'm going to keep that right around 10. And it's going to click up a little bit. So we're going to have minimal interaction between these two tubes right here. And that's good for building, but it's not the end of the world if they touch. Now, we're going to close this out, and I'm going to move on to my chainstays. So my chainstays don't line up here. I want these to line up perfectly. So I'm just going to kind of double check and just kind of guess and check, add a little bit of distance to get those to line up. So I changed it to 55. They're almost lined up perfectly. I'm going to try 58 and see, and that looks really nice. They make this nice little X right here. I know that they're lined up perfectly. So that's just aesthetics for me, but I like the idea of having this nice straight line through and through. We can also go in and change our handlebar, as I mentioned in class today. We can go with any sort of standard. There's generic BMX, generic ergo drop, generic track. That's not going to give us anything. So I'm going to go with a mountain bar. I don't want this much rise. That's B. I want 2 inches of rise, which we determined was 50.8, but you can change that all you want. If you wanted it to be a little bit higher, like a 4-inch riser, that would be 101.6, double 50.8. So that would be a 4-inch riser bar. You know, you can mess around with that. This is not part of the actual frame design anyway, so it doesn't really matter what size bar you're using, but it's kind of nice to be able to envision what the bike is going to look like. We're also going to change the angle. So we want this angle to line up with this angle. We decided today that it's whatever the head tube angle is subtracted from 90 degrees. So in this case, it's 90 minus 68. So 90 minus 68 is going to give us 22 degrees. If we punch in 22 degrees there, this is going to kick back to the same angle as our head tube. We can shorten the stem. So I'm going to shorten that to 50 millimeters if I want a shorter stem. If you wanted a longer stem for whatever reason, you would do so. But typically, unless it's a road bike that you're using for racing, you're not going to have a stem that's longer than 100 millimeters. We can now do things like do our water bottles. We went over this in class, but I'll show you one more time. Here I have water bottle bolts that are way too high, and I don't think a water bottle will actually fit on this seat tube. So I'm going to show my water bottles. We have the first one, which is usually the down tube at 200 millimeters from the bottom bracket, and the top one is way too high. So we're just going to remove number 2, and we're going to make this one be 150 millimeters from the bottom bracket. So long as this doesn't crash in here, we're good to go. So I could even bring that down a little bit to 125 and see if that's good. And that's probably about good for this. You can choose the type of bottle cage you're going to use, whether it be an aero cage or a non-aero cage. I like the traditional kind. And then actually in the web-based version, there are more choices than I have here. So that's interesting. So the web-based version is more updated than my version. So this is looking like the bike we want it to look like. Now, if we wanted to, we could add our cranks back into place. So the thing about this one is that this is a double crank set, and I want it to be something less than that. I want it to be a single chainring. So I'm going to change it to one chainring and make that chainring 40 teeth, which is going to be a smaller chainring. I also want to change the size of these because remember, this is a kid's bike. So I'm going to use a kid size crank, which is 152 millimeters. Most mountain bike cranks are 175. Road cranks can be 170 or 172.5 or 175. So depending on what you're building, you can change those around. This bike's going to be designed to use kind of either or. So I might even change it to a 170 just to kind of see what that's going to look like. And then we're going to be able to view our cranks. And there's our cranks. You know, there are other things you can do, like change the number of splines on the spider. So a 4-bolt pattern, which would be more of a classic mountain bike pattern. You know, you can change the diameter of some of these things, but honestly, we're just trying to get a general look and feel for what these cranks are going to look like. So I think this is pretty good. You can also change the angle of the crank if you wanted to, just to check, you know, like if you wanted to check clearance with the ground. You know, at the bottom of this crank rotation here, we might see, oh, those cranks are pretty close to the ground, so we might want to do something about it. In this case, this isn't that big of a deal because I'm planning on making it so that I can put a bigger wheel on the bike as my daughter grows, and that'll bring the cranks up off the ground a little bit if we ever have to change the size of the cranks. So, but if this seemed like an issue, I could always raise the bottom bracket up a little bit and not do so much bottom bracket drop on the bike. It's entirely up to the builder to do that. So with a 152 millimeter crank, it's looking significantly better in terms of that crank clearance off the ground there. So we're going to leave it at that. I can also install pedals. And again, with pedals, I don't really want to go custom. I'm just going to go like a standard SPD pedal. So that's going to be like a mountain pedal. It'll look like that. Hello. Okay,